Okay, good morning. So this video is going to be on resistors and resistor colors. So this is typically what you would see. I believe that's a 1K resistor. And there's so many different charts we can look at. I think that I've basically taken this one because it works with decimals, whereas if you look at maybe the first one, it works with 10 to the power of whatever. And so that's a little bit more confusing for you, but essentially the number here just represents how many zeros would be, and it gets a little tricky here when it actually reduces it by 1. But we're going to look at the colors. The 5 takeaways that we want from this is that TinkerCad does make a mistake from 1 to 9 ohms, so that's going to be this range here, and it's just in the color band, so it's not super important. There is more than one color system. There is 4 resistors that have 4 stripes. There's some that have 5. Some of them have numbers written on them. And then when you get into the surface mount, they're a whole different ball game. Small differences in values makes usually little or no difference in a circuit. It of course does make a difference, and you can calculate that, but typically it's not a big deal. Different colors represent different values, and there is kind of a rainbow influence. I don't know if you can tell, but if you look right here, you've got red, orange, yellow, green, blue, violet, and that's kind of the rainbow. We also have gray and white tacked on, and then brown on the top and black as well. Okay, so the way we're going to do this is we're going to start with 1 and go all the way to 30, and we're going to bring in a chart to help us. So let me see if I can zoom in and have the chart still there. So this one should be 1, so brown would be 1 in the first band, and that's why there's brown out here, just to highlight that. And then the second one is black, so 1 and 0 would be 10, and that's where you need this gold multiplier, where 10 times 0.1 will actually bring it down to 1. So there should be a gold band here. Now if you drop down these numbers, you don't actually have gold, so I can't show that. Let's see if I can bring that back. So let's hide that again and bring this back again. Okay, so number 2 is going to be 2 in the first band, and then it's black in the second one, and then again with that multiple of gold, it's going to bring it back to 2 instead of 20. And then we go down basically through the colors. So if you see, I've chosen this breadboard because it actually has the numbers. So it goes 1 for brown, and 2 for red, 3 for orange, 4 for yellow, 5 for green. Now 6 for blue. On the keyboard it's actually 7, but that you can get used to that. And then purple, you can see, is 7. 8 is white. 8 is gray, sorry, and 9 is white. So that's how the number systems go. Now you'll notice that the second color is always black for the first ones, and that's because black is basically a 0 in this system, and they're all going to be the same until we get to number 10. So number 10 is going to be brown for the first color, black for the second color, and then the multiplier is going to be black as well, which is 1. So if you take 1 and then 0, so that's 10, and then times it by 1, you're still going to get 10. So that's going to be true as far as multiplier goes all the way down, because we never get out of basically multiplying by 10. So that's why all these are black. So now these ones here, 10 to 19, are all going to be brown in the first column, because 10 all the way through 19 is going to have the first digit as brown. And then it's just going to go the second digit. So it's going to start with 0, and then it's going to go 1 and 2 and 3 and 4 and 5 and 6 all the way down to 9. So when we get to 20, 20 is going to have a new digit in the first column. So that's going to be 2. And that's going to hold true for all of them up until 30, where 30 is going to have an orange in the first column. So that's a 3. And we just have differences in the second column because all the multipliers are the same for these ones. And it just goes through the basically the colors here. So starting with 0, and then, is that correct? This should be brown. So brown is 0 on the keyboard. And we made one mistake there. And then it goes through. So it always goes brown, red, orange, yellow, green, blue, purple, gray, white, and then it starts again. So it's going to be black, brown, red, orange, yellow, all the way through. And that's the sort of the pattern that it's going to go through. So whichever number stays the same in the 20s, it's always going to be a red in the front. And then the significant changes are going to be in the second color. So that's kind of confusing, but if you keep the pattern going, you should be able to make sense of it. You can always put your mouse on the resistor, and let's try it again. You can sort of set it to whatever value you want, and that confirms what you think it should be. Okay, so the second and last pattern that we're going to go through before we take a look at the most common resistors is essentially when we're working with the 1000 multiplier, right? So a very common resistor is this one, and it's 1. So if you see here, it's 1K. And so if we go through this one, we have in the first one is a 1. So we look at 1, it's in the first band. The second number is 0. And then the multiplier is red. So the red one is actually timesing by 100. So if you take 10 and times it by 100 and think of how many zeros you have, you're going to have 3 zeros. And that's what the K represents. The K is like 1,000, so we're going to think of as 1,000. Now the next one is going to be 2, and then 3, and then 4. You'll notice that the second ribbons or bands are always the same because we're still timesing it by 100, which is basically 2 decimals. You can think of as red as these will be the number of zeros that you'll be timesing by. Orange would be 3 of them, and yellow would be 4 of them, even though the K represents that. Okay, so what you're going to do is you're going to see what kind of student you are going to be. You could repeat these if you want. It does seem a little torturous. The main things that I want you to notice is that if it starts with the same value, so in other words 10 all the way to 19, it's going to have a brown band in it. If it's going to have a 2 in the front, it's going to have a red band in the front. If it's going to have a 3, it's going to be orange. If the front number is going to be the same, then the second number has to kind of go through this sequence all the way from black all the way to white. So that's where you see these patterns showing up. And have I made a mistake here? No, because the first one is changing, the second one is staying the same, and then this one is changing, and then we go through that color sequence twice. Okay, and always the multiplier is red for the first 9, and then it goes to orange, which I think is correct for the second one, and you can tell in the third band. Okay, so that's essentially it for the sort of the patterns, and you could choose anything that you want for patterns. You don't have to choose these values. You could make whatever you want. And then these are the most common ones. So 1K is typically the most common resistor that you would see, and the most confusing thing is that it's basically opposite to 200. Now, if you were to put this in a circuit, this would be a very dim LED at 5 volts, and this one would be a pretty bright LED at 5 volts, and then we often use maybe 220 because these are very similar, and it's really easy to tell that this one is red, red, brown, whereas this one looks pretty much like that one, and it can be mistaken depending on how comfortable you are. 10K again is used for pulling down a value on a pin or a switch just so that it doesn't show a false high. And then these are essentially a very dim LED. This would be a very bright LED. And then it would get sort of this range would just be for limiting the current to the LEDs. Okay, so hopefully that makes sense. I'll just leave you off with this sort of final thing that we want to walk away with these bits of information that TinkerCad isn't perfect, especially in the lower end. Typically we don't use those resistor values because wire itself is going to be pretty close to that value. There are more than one system, so I'm not really worried that you learn these. I just want you to be aware of what's happening. Small differences in the value are going to make very little difference. So a 150 versus a 100 isn't going to be a huge difference, and we're going to typically use these as interchangeable depending what we have available, and different colors or different values, and you can kind of maybe use the rainbow if you like to do that to remember to help you with the pattern, and that's it. So good luck with that assignment and have fun doing it.